So 2.5 is talking about rational equations in one variable. We want to learn how to solve rational equations and applications of rational equations. All right, so let's start out with the definition. A rational equation is an equation that contains at least one rational expression, while any non-rational expressions are polynomials. Okay, so an example. We want to solve the following rational equations. And remember, I encourage you to either download these notes, print them if that's the way you do it. If you don't print them and you want to use your tablet, that's fine. But remember, I'm leaving space for you to actually fill in the blanks because we're not going to spend the entire time for you to write it down. Okay, so make sure you're on top of that. So example 1. Solve the following rational equations. Part A, we have negative x squared over x minus 1 minus 3 equals 0. So right now, we want to solve this for x. Our goal is to solve the following rational equation. So in order to do that, we need to solve for x. So this x minus 1 is in the denominator. There are a few ways we can go about doing this. I'm going to choose to eliminate the rational expression, which means we want to multiply each part by what? We want to do what? Which is? Yes, we want to multiply everything by x minus 1. So that's what we're going to do. We're going to multiply both sides of the equation by x minus 1. This is not written correctly as I'm writing it, because the way I've written it, it looks like we're only multiplying what by what's in parentheses. That's not written properly. What should I do?
Can't you just put the x minus 1 next to it? Like,
But that's what we did.
why are we talking about like in different?
Should it only be to the fraction and not the other number?
You said, should we only multiply x minus 1 by this?
Mm-hmm.
Does it look like we're multiplying x minus 1 times all of this? No, what does it look like we're multiplying? It looks like we're multiplying this negative 1 by this. So in order to say we're multiplying all of this by x minus 1, what do we need to do? Put what? I heard two different things.
I was going to say, put in parentheses.
Put what? What's your it?
The x minus 1.
Put x minus 1 in parentheses. Put x minus 1 in parentheses. Good. Put x minus 1 in parentheses. I also heard someone say you can do what? Put it over 1. You can put it over 1 if you wish. That's okay. So you look like you're multiplying a rational expression by a rational expression. That's all right. There's nothing wrong with it. Anything divided by 1 is the anything. But make sure what you're writing is what you mean. That's the point. Okay? So what does this mean? This means that we have x minus 1 times negative x squared over x minus 1 minus x minus 1, that quantity, times 3 equals, what's x minus 1? Well, x minus 1, that quantity, times 0. So now we multiply. You said you wanted to put it over 1. That's all right. There's no need for the rest of them. But to see that, this cancels out. What are we left with? Negative x squared. Good. Minus, we're going to distribute this 3. So what do we have? Minus, careful because you also have this negative up front. We have what? What happened to the rest of it?
What you mean?
Oh.
Let's rewrite it first since there's a little bit of hesitation. So let's put the 3 up front times the quantity x minus 1. Does that make it more appealing? Okay. What's x minus 1 times 0? 0, right? So now tell me what you have on the left.
Negative x squared minus 3x plus 3.
Yes. Is that it?
Equals 0.
Equals 0. Why is it what?
Plus 3.
Because you're distributing a negative. So because you're distributing this negative here, that's a negative 3, and a negative times a negative is a positive, so that becomes a plus. Yes?
Why didn't the subtraction sign stay with 3?
Yeah, right there.
Here?
No, from the,
Where you're multiplying.
on the first and second line?
Here?
Yes.
Why did what?
Why did it not stay when we moved it down?
It did. It's here.
Why is
Well,
this-
it didn't stay with the 3.
What do you mean? It's
That's why
here?
I thought the 3 was positive, so.
Oh, but we moved it? But this didn't change. The sign didn't change. So I see what you're saying. So let's point it out. Let's follow the yellow. So here is minus, right? Here is minus, right? So we distributed this to both. Are we okay? Do you mean it? Yes? Okay. So here, these two, this is the same thing as this.
Oh, you just broke it down.
Yeah, because you all hesitated.
You just switched, okay.
So whenever there was hesitation, whenever I said we distribute this 3, there was hesitation, so I wrote it in a way that you're used to seeing it.
Oh,
When you multiply two things like this, they're the same thing no matter the order you put it in, as long as you're multiplying the quantities. You have to be careful. Notice that the sign, that's still that. But now, when you distribute, you're really distributing this negative 3 to both. Are we all on the same page now?
Yes.
Yes.
On the third
Talk loud. Third line. Here.
line, how did x minus 1 and 3 get on its own parentheses?
Here. So we are distributing. Let's see. We're distributing this quantity to each part here. So that really looks like this time and then that times each part here. So, see, you're not the only one with the question. So, this is what happens when you distribute that x minus 1. So, we kept this in parentheses, so you're multiplying this quantity x minus 1 times this 3. Because if you do not put parentheses around it, it looks like you're just multiplying the negative 1 times 3, when you really mean you're multiplying the quantity x minus 1 times 3. Does that make sense?
So on the fourth line, you just took the x minus 1 is on the third line and moved it to the left?
This line?
Uh-huh.
Yes, we just moved this 3 to the other side because if you have, just in general, if you have A times B, that's the same thing as B times A, right? If you have 2 times 3, that's the same thing as 3 times 2. So all I'm saying is you have x minus 1 times 3 here, and that's the same thing as 3 times x minus 1. What other questions do you all have? Does that make sense? Yes or no?
Yes.
Okay. So now we've gotten this to a what type of equation? No yawning. Get it together. It's a what kind of equation? Quadratic. Let's use the quadratic formula and finish it. So let's use the quadratic formula. What is it? What's the quadratic formula?
Negative b plus or minus the square root of b squared
Good. Okay, and that's going to be x. Okay, so what's a for us?
Negative 1.
What's b?
Negative
What's c?
3.
So let's solve it. Okay, so you can use your calculators if you like, but I expect you to be able to at least write out this first step. Bless you. Negative times negative 3 plus or minus the square root of what?
Negative 3 squared.
Written like this? Uh-uh. Around what?
The other three.
Around what?
B. Yo, B.
Around what we have? Parentheses around what?
Negative 3.
Oh, negative 3? Okay, good. Minus 4 times negative 1 times what? 3, good. All of that over 2 times negative 1. Good. You can use your calculators if you want to. If you want to. I'm going to do it by hand because that's what I'm doing, but you can feel free to check. If you're using a calculator, you want to make sure you know how to use it. Okay? All right, but I do expect to at least see this first step where you substitute everything in. So now, negative times a negative is a positive, so that's 3 plus or minus. Negative 3 squared is what? Negative 3 times negative 3 is what? 9. Good. So let me make sure you understand that these are not the same. So this is 3 plus or minus the square root of 9. We're subtracting a negative, so this is going to become a positive. What's 4 times 1? 4 times 3 is? So plus 12 all over what? Negative 2. Good. So this is going to become 3 plus or minus the square root of 21 all over negative 2. Is there a perfect square inside of 21? No. It's 3. 21 is what times what? 7 times 3. So neither one is a perfect square. So we cannot simplify this. So your solutions will be 3 plus the square root of 21 over negative 2, or 3 minus the square root of 21 over negative 2. And it's possible for you to move this negative up top and say negative 3 minus the square root of 21 over 2, and then have negative 3 plus the square root of 21 over 2. They're the same thing. Okay? So that's our solution. What questions do you have? Contain your yawning. Yes.
It's just a little off topic, but it reminds me of a question I had yesterday.
Yeah.
For our solution set, say we have I, do you want us to put the I in front of the square root, or do you want the I to be next to the,
So what you're saying is you don't just have I. What you're saying, what your question is if you have I, and if you have the square root of 2 times I, your question is, I want the I in the front or the back? Was that your question? What was your question?
So say it's there is a perfect square inside of the,
Give me an example of what you're trying to say. Tell me, go ahead. If you have what? No, you can just tell me. What is
I
it?
can't remember the equation I had yesterday.
Let me know when you're ready. Does anyone have, go ahead.
Sorry. It was 1 plus or minus I square root 6 over 7.
All over 7?
Yes.
Go ahead. So what's your question?
Do you want us to write it like that, or do you want us to write it 1 plus or minus the square root of 6 over 7I?
You said or 1 plus or minus the square root of 6 over 7. And where did you put your I?
At the end.
That's not the same thing.
So I'm saying, okay.
No. So this is different from this because you're only multiplying the square root of 6 times I. So you can write it like, you can put this, but make sure that I does not appear like it's underneath the square root. Or you can write your answer as 1 over 7 plus or minus the square root of 6 over 7 times I. That's how you write it as a complex number.
Oh.
And you need to be comfortable identifying it this way.
Can I ask a question?
Yes?
Because I thought the plus and minus already represented the I.
I can't hear you.
I said I thought the plus or minus already represented like I.
No, what represents I?
Negative.
No, not a negative square root. There's a difference between a negative square root and I. What's I?
The square root of a negative number,
I is the square root of what particularly?
a negative number.
What specifically?
Negative one.
This I is the square root of -1. Yo, y'all in is mad loud.
I'm sorry.
I is equal to the square root of what?
Negative one.
Yeah, so go ahead. What's the rest of your question?
No, that was it.
I is the square root of -1. What other questions do you all have? Okay, all right. So let's look at another example. Part B, we have z over 6 plus 7 plus z minus 1 over 6 minus z equals z over 6 minus z. Okay, we have z over 6 plus z plus z minus 1 over 6 minus z equals z over 6 minus z. So for this particular rational equation, right? It's a rational equation in one variable. What's the variable? Z. Good. So what do you think we want to multiply everything by here?
Six minus.
I would, yeah, I said 6 minus
6 minus z? Is that it?
At least for me.
6 minus z? Is that it? Is that going to eliminate all the rational expressions?
I think the 6 plus z on the one that's -2.
Say what?
Put the 6 plus z on the ones that's -2.
Where's -2? There no -2.
Like the 6 minus z, the both of them that's negative, they need the 6.
What do you mean, the both of them that's negative? You mean 6 minus z?
6 plus z. Like,
You
put
s-
it in the
you-
parentheses and put
You
the-
said multiply this one by 6 plus z?
No. The 6 plus z, if you're gonna put the 6 minus z, I think that you should put 6 plus z on the other two. Like. if
So
you-
you're saying put 6 plus z here.
Yeah,
But is that going to eliminate your rational expression?
I don't know, I'm guessing.
Yeah, you do, you know.
Oh.
Is it going to eliminate this rational expression?
I think so.
If you put,
I was trying to get all the denominators.
that's what I'm asking.
Oh,
Listen,
okay.
if you put a 6 plus z here, is that going to make this rational expression go away?
Yeah.
How?
They'll all be alike though, 'cause one be.
What do you mean? Let's answer her question. Is it going to make this rational expression go away? What is going to make this rational expression go away?
Timing it by 6 minus z.
Multiplying it by 6 minus z. Because if you multiply by 6 minus z, that's going to cancel out with this one. But is that going to help us here? No. So do we just multiply by 6 minus z?
No, we didn't. Multiply by something that's gonna make them all the same.
Multiply by something that's going to, what do you mean make them all?
It's gonna make them all the same denominator.
So what's that?
You saying what's that as in like?
6 multiplied by 6.
6 times 6 is what? 36. Will that make the z's, the 6 plus z go away or the 6 minus z go away? What will make the 6 plus z and the 6 minus z go away?
They all gotta end up the track.
Z minus 1.
Where does z minus 1 come from?
Yeah, second one.
The numerator?
Yeah.
But we're trying to make what go away?
Denominator.
The denominator. Can't hear you. Can you do what? Square what? Square what? If you square, you're talking about the original equation? Are you talking about the original equation? If you square the original equation, that's just going to make twice of what you already have in each spot. If we have x over 2 plus 2 over 3 equals 5 over 3, how can we make the denominators go away?
By the greatest common, no.
We multiply everything by what? Tell me exactly what we're going to multiply by. I gave you something very specific. You have x over 2 plus 2/3 equals 5/3. If you want to eliminate the rational expressions, what do we do?
Well, for that, we talked about 6 because.
Oh, we multiply everything by what?
6.
Why?
Because 2 and 3 can go into 6.
Oh, what did you do to get 6?
Because I know 2 times 3 is
You multiplied 2 times 3 and you got?
6.
It's the same process. You just got z involved. You got 6 plus z times 6 minus z. Or you got z over 6 plus z plus z minus 1 over 6 minus z equals z over 6 minus z. So you want to multiply everything by 6 plus z and times what?
36.
No. You want what? So, pause. Let's make sure we all on the same page. Did everybody understand here that if we want to solve, we need to multiply everything by what? Okay, so you said multiply everything by 6, so that would be x over 2. And instead of 6, I'm just going to write times 2 times 3 over 2 times 3. Or no, let's just let's put that over 1 plus 2 over 3 times 6, which is 2 times 3 over 1 equals 5 over 3 times 6. And then what happens is the 2's cancel, leaving us with 3 times x plus the what cancels in the next part? Come on, what cancels in the next part? The 3's, leaving us with 2 times what? 2 equals what happens in the next part? The 3's cancel, leaving us with what? 5 times 2. Notice that we eliminate the fractions. Same thing up here. You have 6 plus z in the denominator. You have 6 minus z in the denominator here and 6 minus z in the denominator here. We're going to multiply each part by what?
We just said 6, right?
No, why are you just choosing 6? I just gave you an example with numbers to help you identify the process of what you should do.
I think restricting us
It's the variable.
It's the variables, but I just gave you an example that didn't have variables so you can identify the process.
Can it either be 3 or 2?
No, those were just random numbers. This was just a random example. You said can you use 3 and 2? No, because the denominator is 6 plus 7 here, 6 plus z here, 6 minus z here, 6 minus z here. What do we need to multiply everything by in order to eliminate the rational expressions? What? No, we didn't use a reciprocal here. Yeah, you are.
I say, can we multiply by ourselves?
What do you mean? What's itself?
6. If we look at
No, but you're only taking part of it. That's what I'm saying. You're only taking 6.
So we need
This is 6 plus z in your denominator.
Okay, so we need the variable constant.
So again, my question is, what do we need to multiply all of this by to eliminate the rational expressions? I can't hear you. Z? No, you're taking part of the denominator. Did we take part of the denominator here? No, what did you take? The whole denominator, y'all. So what do? 6 plus z, say it loud. Say it loud.
6 plus z times 6 minus z.
Absolutely. Yes, that's what we do. Yes, you can applaud because it was good. Okay, you can do better. Yes? Okay, so you multiply everything by 6 plus z times 6 minus z. So that's what we're going to do. Okay? They're just variables. It's just an expression. It's the same process as this here. So we're going to multiply everything by 6 plus z times 6 minus z. I'm going to erase that green and yellow example, okay?
Keep it up there.
I left it up there for a minute.
I was trying to write it on the first page.
You got it? Okay, so this means that we have 6, the quantity 6 plus z times the quantity 6 minus z. So now we're going to distribute this to each part. We're going to distribute this to each part. You with me? Yes or no? Okay, so times z over 6 plus z plus 6 plus z times 6 minus z times what?
3 minus 1 over 6 minus z.
Yes. Equals, we can just go ahead and simplify on the left, on the right, what happens? What happens on the right?
Cancel out and be 0.
What's it? What cancels?
6 minus
The 6 minus z's cancel, but does that give us 0? No. What does it give us? What? You said
It
z?
gives us 6 plus 2.
Plus z squared.
Just don't simplify it all the way. 6 plus z, that quantity times what? Yes. Yes. What happens on the left side?
The 6 plus z cancels out.
These cancel out to leave us with what?
6 minus z times z.
Yes. What happens next?
The 6 minus z cancels out.
So what sign do we put here?
Plus.
This plus comes from here.
Yes.
What?
6 plus z
Talk loud.
times z minus 1.
Good. Equals what?
6 plus z times z.
The quantity 6 plus z, either one, 6 plus z times z. Okay? Now we can simplify. 6 minus z times z is what?
6z minus z squared.
Good. What do you do for the next part?
And plus
What do you have to do? Using what method?
4.
FOIL, yes? First, outside, inside, last. What do you get?
6z squared.
Outside.
Oh, 6 negative 6.
Inside.
Z squared. And
minus z. So I used green to demonstrate we're using the FOIL method. Equals what?
Equals 6z plus z squared.
Plus z squared. Everyone agree? Yes, no?
Yes.
Okay, so now our goal, what is our ultimate goal?
Combine that one.
No, what is our ultimate goal? Our overall goal is to do what? What's our overall goal? Solve. That's our goal. That's our goal. Our goal is to solve. So we need to combine like terms. But to combine like terms, we should do what first? Get everything on one side. Yes? So move the 6z and the z squared to the other side, which means we have to do what? That's right, subtract them. So minus 6z, and then subtract z squared. So that's going to become 6z minus z squared. You want me to stick with the colors or no? Can we just write it, or you want the colors? I didn't hear you. Okay, so plus 6z minus 6 plus z squared minus z minus 6z, this is the yellow now, minus z squared equals what?
0.
0. Good. Now we're going to combine like terms.
You got 2 6Z's and
So you got a 6z, a 6z. What other things have z? A negative 6z, you said, and a negative z. And then your other like terms would be
Z squared.
is that it?
This is one other one.
One other what?
Z squared.
Is positive or negative? Okay. And then you have your what? And then you have a negative 6. So adding up the green, you have a negative z squared plus z squared minus z squared gives you what?
Negative z squared.
Negative z squared. And then adding up your terms involving z, 6z plus 6z is 12z minus z is 11z minus 6z is
5Z, negative 5Z, negative, no,
Positive.
it's 5Z.
which one?
Plus 5Z,
Plus 5z, and then
minus
minus 6 equals 0. Do you like the fact that there's a negative 1 in front of your z? You said not really? Okay, so factor out a negative 1 from everything on the left and divide both sides by negative 1. So I'm going to draw just because I'm running out of room. So we're going to factor out a negative 1 because you all say you didn't want I asked if you wanted the negative in front of that. So that becomes negative 1 times the quantity z squared minus 5z plus 6 equals 0. Then we're going to divide both sides by negative 1. So this is going to be negative 1 times this quantity all over negative 1 equals 0 over negative 1. What that does is that cancels out those negative 1s and leaves you with a z squared minus 5z plus 6 equals 0. So all that did for us is it just made the coefficient of z squared positive. Now you can do what with this, yes?
Why you flip the 2 signs?
Which 2 signs?
So at the bottom
Here?
is yes, ma'am.
We factored out a negative.
So when you factor, you gotta switch the sign.
When you factor out a negative, the signs change.
Okay.
So notice that this became a positive, this became a negative, and that became a positive because if you distribute this, you want to get the same exact thing as this.
Okay.
That makes sense?
Yes, ma'am.
Okay. What other questions do you all have? Okay, so we want to solve. What can you do? Quadratic formula? Or you can factor it as what? You said z minus 3 and z minus 2? That product equals 0? Okay. So what does that mean? Good. So z equals 3 and z equals 2. So that's our solution set. Questions? Okay. All right. Let's look at another example. Here, we have 3 divided by, can everyone see that? Can you see that in the back? No? Zoom in. Is that better? I can't hear you. Is that better? If you said no, I need you to respond. Is that better? Yes or no?
Yes.
Okay. So you have 3 over the absolute value of x plus 1 equals 1. Our goal is to solve still. So we're going to multiply everything by x plus the absolute value of x plus 1. So we get that. And so then we have to remember what it means for us to have the absolute value, which we've talked about. So that means we have 3 is equal to -1 times the quantity x plus 1, or we, to get from here to here, we multiply everything by, no, the absolute value of x plus 1. You multiply everything by that, so then these x plus 1s canceled out. Does that make sense?
Yes, ma'am.
Okay. Okay. Are we all okay? Okay, so now we have 3 equals -1 times the quantity x plus 1, or we just get 3 equals x plus 1. That's what happens. Okay? So, we then have, are you recording this? Okay. So we then have to do what over here? Distribute the negative, yes. So then we have 3 equals what? Good. Now what? To get? Hold on, let me write. 4 equals -x, and then what? And to get that, you get, divide both sides by -1. To get -4 equals x. So that's 1, very good. Or you have 3 is equal to x plus 1. You do what to both sides? To get what? 2 equals x. So our solution set is what? -4 and 2. Good. What questions do you have? Okay. All right. So we're not going to spend a whole lot of time on the next, but I think you should see it just because applications are important. So let's review it. Okay. So there are many different applications known as what's called work rate problems. These applications have in common 2 or more workers acting in unison to complete one task. The goal in a work rate problem is usually to determine how fast the task at hand can be completed, either by the workers together or by one of the workers themselves. facts. There are two keys to solving a work rate problem, and that's the following. The rate of work is the reciprocal of the time needed to complete the task. The rate of work is the reciprocal of the time needed to complete the task. If you're questioning what words mean, you should use what? The Mass Dictionary app, right? So if a given job can be done by a worker in X units of time, the worker works at a rate of what? This says the rate of work is the reciprocal of the time needed to complete the task. If a given job can be done by a worker in X units of time, the worker works at a rate of what? What does this say? Can you read this to me? Oh, it's the what? What does reciprocal mean? Reciprocal and opposite, are they the same? No, they're not. Say it again. I can't hear you. Flip what? Give me an example.
So would it be 1 over X?
We're going to stick with that thought. You're going back to the thing. Let's make sure we understand the reciprocal. You say you flip it. What's your it? Give me an example. If you say 2, wait a minute. If you say 2, it'll be 1 over 2. That's reciprocal, right? Yes? No? Okay, so if you have 2, the reciprocal of 2 is what? 1 over 2. The opposite of 2 is? Negative 2. They're different. Yes? Okay, so again, if you have 2, the reciprocal of 2 is? The opposite of 2 is? They're different. Okay? So here I say that if a given job can be done by a worker in X units of time, the worker works at a rate of what? 1 over X, right? Because it's the what? Reciprocal, yeah. Jobs are per unit of time. So, as an example, if a faucet can fill a sink in 3 minutes, its rate is what? 1 over 3, yeah. 1 over 3 of the sink per minute, right? So, rates of work are additive. Rates of work are additive. So ideally, 2 workers working together on the same task will have a combined rate of work that is the sum of their individual rates. Okay? So if Frank's rate in overhauling an engine is 1/2 and Toya's rate is 1/5, their combined rate is 1/2 plus 1/5 or 7/10. Okay? That is together they can overhaul an engine in 10 over 7 hours because we think of it as the reciprocal, right? Or if we're thinking about it in time, that's going to be 1 hour and 26 minutes. Okay? So let's look at an example. And we'll just do one. If you want to see the second one, we can. But I want us to make sure we go on to the next section too. Okay. Solve the following applications. The hot water tap can fill a sink in 4 minutes. If the cold water tap is turned on as well, the sink fills in 1 minute. How long would it take for the cold water tap to fill the sink alone? Okay? So, the hot water tap can fill a sink in what?
1 minute.
Okay? So that's equivalent to what? Oh, good. 1/4. Yes? And then it says if the cold water tap is turned on as well, the sink fills in 1 minute. How long would it take for the cold water tap to fill the sink alone? So 1/4 plus, do we know what we're adding? So if, what?
Plus one,
Where's the plus one coming from?
because it fills up in 1 minute. And
What fills up?
the sink.
The sink. So that you're talking about the entire sink.
Yes. Goes up to
So are we adding one, or are we setting this sum of whatever equal to one? The sum of whatever is going to equal to 1 because it takes 1 whole minute for the sink to fill. Does that make sense? Okay. So we have to figure out the whatever is, right? So that's going to be 1 over x because we don't know. Okay? So we're back to a rational equation and one variable. What do we need to multiply everything by? 4 times x, yes. That spending the time on the other example was well worth it. We multiply everything by 4 times x. You better believe it. So we're going to multiply everything by 4 times x. So that's 4x. If you can put it over 1 if you want to, that's okay. That's perfectly fine if you want to put that over 1, that being your 4x. Four x times 1 is just 4x. What happens on the left? What cancels? Yes, the 4's cancel, leaving us with what? X, yes. Then the x is canceled, leaving us with?
4.
Equals. Now do what? Yeah, sure. To get what?
3x.
To get what?
4x.
Hey. So what? You said subtract x from both sides. What's left on the left?
3x.
4.
Oh, 4 equals 3x.
Oh. 4 equals 3x. You flipped it. And I'm okay with that. But let's read what we had. So 4 equals 3x, yes? Then divide both sides by? So we get 4 over 3 equals 3x over 3. What happens? 3's cancel to give us 4 over 3 equals x. We're talking about what as our unit? What as our unit? From the question, yes. So 4/3 minutes or 1 minute and 20 seconds. Okay, are you good on this? Okay, so part B you can do on your own. That's 2.5. That's section 2.5. Okay, so now we're going to talk about radical equations in one variable. We're going to talk about radical equations in one variable. Section 2.6. Yes? Oh, you're just stretching. Okay. You good? Yes? No? Got so excited.